Today we're going to continue on chapter 3. We talked about reactions before, and that reactions change one or two substances in one or two other substances, and you made a chemical equation in words already. In chemistry we don't really like words because they're long and it takes a lot of time to write them down, so we prefer to use chemical formulas. And a chemical formula basically states which atoms and how many of them. First we're going to talk about a molecular formula. There are two different ones, and molecular is the first one. A molecular formula only states which and how many, not exactly how they are arranged. For example, H2O. It says it has the atom H, and this number says I have two of them. This thing says I have atom O, and since there's no number here, that means that I have one of them. So nothing means when nothing is here, it means there's only one. Because if there would have been 0, I wouldn't have written them down. H2O, you might know, is water. It represents water. And you can also draw a structural formula of it. And a structural formula not only states how many and which, but also how are they arranged. How are they arranged? And when you draw this, it has one O and two H's. And this is how you draw water. You don't have to remember structural formulas, you do have to recognize them. So if you see this, it means that you should know, oh wait, these are two H's and one O, so it's H2O. That is what is important. For now, it's not that important to learn all those things by heart, because you can find on its learning a file. We'll come to that one later. Okay, so we have H2O. More examples are, for example, CO2, which is carbon dioxide. It has one C and it has 2 times an O. If I want to draw this thing, it looks like this. I have one C and 2 O's. There's a double bond in between. You don't have to know that. You should know, if you see this, I have one C, 2 O's. I, for example, have SO2, which is sulfur dioxide, and it has one S and 2 times an O. There are more, like C12, H22O11, which is sugar. I'm not going to draw it if you don't mind, but it has 12 times a C, 22 times an H, and 11 times an O. Okay. If you want to draw a chemical equation, then you need to know the words and the formulas. And therefore there is a worksheet on its learning, and it says chemical formula. There you can find loads of formulas and words, and you can use it on both your exercises and your test. Some examples of a chemical equation. We are going to start on an easy one. We're going to make water from oxygen and hydrogen. You don't have to learn any of these by heart. You will get this sentence and then you have to form your own equation. To form this equation we need to know water, we need to know oxygen, and we need to know hydrogen. We're going to form water, so water will be last, from oxygen and hydrogen, so oxygen and hydrogen will be first. Last time we already talked about chemical equation in words, so first we're going to write down in words. So step 1, write the equation in words. Well, here it says oxygen plus hydrogen makes water. 2, from words to chemical formulas. If you take the paper, on its learning it says oxygen is O2. Oxygen is a bit weird because it's always together. It's called diatomic molecule, and it always wants to be together. It hates being alone. Hydrogen is the same. If you check your schedule, it says, your worksheet, it says H2. And to form water, water is obviously H2O. Okay, 3, and now this is going to be the hardest part. We need to balance the equation. And balancing equations means number of atoms before reaction should be the same as number of atoms after reaction. That is because atoms cannot get lost, and they cannot like somehow apparate. Too bad. So it's impossible that you have like 2 O's here and 1 there, and then where's the other one? So that is impossible. We need to make sure that before the reaction all the number of atoms are the same as after reaction. Here it's not. So I'm just going to copy this one first. And then I'm going to draw what is actually this. I have 2 O molecules. I have 2 H2 molecules. 2 H molecules, atoms, sorry, not molecules, atoms. And I have O, H, H. Okay, now I have a problem because I have 2 O's here and only 1 there. That is impossible. There's a simple solution for it. I just take 2 of them. So I need... It might feel a bit weird that you can actually just take 2 of them, but it's actually, this one is just not happening. This is what is happening, and you just write down how it actually goes. So it's not weird to take more. Now I have 2 O's here and 2 O's here, so that's perfectly perfect. But I have another problem. I have 2 H's here and 4 of them I have here, which means I need more of these. So I'm just going to write down another one. So now I'm happy because I have 2 O's here, 2 O's here, 2 H's here, 2 H's here, so that makes 4, and I have 4 of them here, so perfect. As you can see, writing this is, well, a lot of work. It's not a problem. You may do it on a test, but in chemistry we mostly don't do this. What we actually do is use a coefficient, which is basically a number before the molecule that actually states how many molecules do I have. So I have 2 of them here, which means I can write a 2 here. This is called a coefficient, and it states how many molecules. So I have a 2 here, which means I have 2 of them, which means 1, 2, 3, 4 H's. I have 2 of them here too, so I can write a 2 here. So now I state that I have 2 H2O molecules, which I actually have. There's nothing here. Just as there's nothing there, there actually is a 1. But we don't write those, so you may just skip the 1. This is how balancing equation goes. It's hard to begin with, so that means that you should go to its learning, and there you can find balancing equations. Please go there, choose game, and try to earn all the stars you need.